Hello guys and welcome. On today's video I'd like us to look at counting and discuss some problems together, okay? Yes. So feel free to pause the video and copy down these questions so that once we start doing the solutions we are on the same page, okay? So the first question there, it says how many integers are there from 10 through 99, okay? So we are starting from 10 through 99. So let me quickly write the solution to that. So in A, I entered how many integers are there from 10 through 99, isn't it? So we see that, okay, we're gonna say 99 minus 10 plus 1. Then that will give us 90. Okay, so the reason we are saying 99 minus 10 then plus 1 is because we are starting from 10. So 10 is being counted as well. So if you count from 10, say 10 up to 99, you'll see that you are counting 90 times. Okay, so that is the whole idea of how you are answering this question, the first one. Okay, so yes, now let's move on to the second one. If you feel like you didn't understand how we do the solution of the first one, feel free to rewind and listen to the explanation carefully. Okay, it's quite an easy example. So the second one say it says how many odd integers are there from 10 through 99. So now they are specifically looking for odd integers. Okay, so we know that for this type of question we are only dealing with 2 digits because it's from 10 to 99, isn't it? So yes, since they are looking for odd integers, we can say, okay, let us see, it's 2 digit. So the first digit can be 1 up to 9. So it's 1 2 up to 9. Okay, so it can go up to 9. 1 2 3 4 5 6 7 8 9 for the first one. Okay, so for the second one, since we want to make it odd, that means this side must be odd, isn't it? Then if that side must be odd, then it implies that we have to have something like 1 3 5 7 9. Okay, so this combination of digit are the ones that are going to make all the odd integers that are there from 10 to 99. So you're going to have 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 32, just like that, isn't it? So now we want to know how many are there. So from here we said it's 1 up to 9. So we have 9. Then we multiply it by here. How many are they? 1 2 3 4 5. So there are 5 of them. Okay, so 9 multiplied by 5, that is going to give us 45. Okay, so that's more like it. Then on C, let us see on C what they're saying. How many integers from 10 throughout 99 have distinct digits? So here you have to pay attention to this word. They have to have distinct digits. Okay, so basically here what they are asking us is that they have to have different. What this word means is that they have to be different. Okay, so the first thing that you have to ask yourself once you see that they're asking you of different, you have to ask yourself which ones are the same, like which ones are not different. So if you are having a pair of 2 digit, then it's 1 1 2 2 3 3, like 11 22 33 44 40 44, then 55 66. So these digits are not different, isn't it? It's 66 33 22, just like that. Then 77 88 99, isn't it? So from 10 up to 99, these are the only digits that are the same. So these digits that I wrote here are not distinct. These ones are not distinct. They are not distinct. Okay, so from the first question, we got the total of digits from 10 up to 9, isn't it? Yes. So if we know how many are not distinct, in this case, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 of them are not distinct. Okay, and we know the total of all the integers from 10 up to 99. So if we subtract the ones that are not distinct, the one that are going to be left off will be distinct. So basically what I mean is that if we say 90 minus 9, that will be 81. So 81 of those are digits are distinct digits. So this is the answer to question C. Okay, so feel free to rewind the video if I lost you in between. Yes, it can be a bit tricky, but once you get the jinx of what's going on, it's gonna be much simpler. Okay, yes. So on D, what is happening on D? They are asking us how many odd integers from 10 through 99 have distinct digits. So now the difference between these two questions is that now here they specified they don't want any integers, but they want odd integers, isn't it? Yes, and they have to have a distinct digit. So for that to be the case, for these odd integers to have distinct digit, let us see how we can go about them. Okay, so remember we said that like for the things to be odd, we need a stream of 1, 2, 3, 4, 5, 6 up to 9. I actually should have just said up to 9. So it's up to 9. So it's 6, 7, 8, 9. So you see I'm gonna run out of space there. Okay. So it's actually up to 9. So it's 1 up to 9 on the first digit. And on the second one, what must happen is that we must strictly have odd numbers. So you must strictly have odd numbers 1, 3, 5, 7, 9, like that. Okay, so in this case what's basically going to happen is that since they want them to be to have distinct digit, okay, they do not have to repeat. That means they have to be different. Okay, that is the same idea. Okay, so let's say the next digit that I want to have is something like uh let's say I want it to start with a 1. Okay, if I want it to start with a 1, then what is gonna happen? If I want it to start with a 1, so I'm choosing this. So this side on the second slot here, there is also a 1. So they have to be different. That means this one is not gonna be counted there. Okay, so the possibility that I have to put numbers is 1, 2, 3, 4. So I have the possibility of putting 4 numbers there. Okay, so yes, that being said is 1 multiplied by 4. Okay, so here if we were to count, it was gonna be what no 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 mm, no 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 let's read the question again. I think I missed something. How many odd integers from 10 to 99 have distinct digits? Okay, the digits have to strictly be distinct. So if you notice here, the ones are repeating, 3 is repeating, 5. So these are not distinct digits. Okay, so I already know on this side I'm gonna need odd. So on this side I had to strictly put even numbers. Sorry about that. Let's do it on the side here. So this is a wrong approach. Okay, that is not going to give us the correct answer that we want. So since we know on this side we strictly want to have odd to make the things to be odd integers. So it's 1, 3, 5, 7, 9. Okay, just like that. Then on this side they have to strictly be even, so we are not supposed to repeat any of this. So that is 2, 4, 6, 8, right? So yeah, so the possible on the first digit, the possibility that is there is to have 1, 2, 3, 4. multiplied by 1, 2, 3, 4, 5, multiplied by 5. So we can add that with when, let's suppose now I want to start with the 1, okay? So if I want to start with the 1, notice that already on the second slot there was a 1 that is being accounted. So I have to exclude that 1. Okay, so if I'm excluding that 1, what are the possible numbers that I can put there? There are only 4 of them, 1, 2, 3, 4. Okay, so that is gonna be 1 and 4. So that implies 1 by 4. Okay, so if I want to start with the 3, it's gonna be 1, then on the second one is gonna be 4 again. So I'm gonna be excluding 3. If I exclude 3, I'm gonna be left with chance. I'm gonna be left with possibilities of 1, 5, 7, 9. Okay, so there are 4 of them again. Just like that, going on for 5, 7, and 9. So basically, I'm gonna do the same thing. How many times? 1, 2, 3, 4, 5 times. For the first time, I do it for 1. Second time, I do it for 3. Third time, I do it for 5. Okay. So here for 3, it's plus 1 by 4. Then I have to do it for 5. So when I do it for 5, I have to exclude the 5 here. So we are starting with 5. So it's going to accommodate that first position. Then I exclude it this side. Then it implies I'm left with 4. Okay. So this is basically what I mean saying I'm going to have to do that 5 times. Okay. So 1, 2, 3. So I did it for 5. I have to do it for 7 as well. So plus it accommodates the first slot, so it was on the second, but they have to be different. Then it means we can no longer have 7 there. Then it leaves us with 4 of them. Then plus I want to start with the 9, so it's gonna accommodate the first slot there. Then it implies it can't be on the second slot since they have to be distinct, like different. Okay, so here then the possible slots that can the possible numbers that can fill this slot are 4 of them. Okay, so yeah, that is basically here 1 by 4 and 1 by 4. Okay, so how many times is 1 by, are we having 1 by 4? 1, 2, 3, 4, 5 times. So in simplicity we can say 4 by 5, this one. Okay, then plus we said we are having 1 by 4 for 1 by 4 5 times. So 1 by 4 we are having it 5 times. Okay, so 1 by 4 is basically 4, then 4 by 5, that is 20, and also here it's 20 again. So we're having 20 plus 20. So 20 plus 20, that will give us 40. That will give us 40. So to answer this question, when they say how many odd integers from 10 to 99 have distinct digit, then there are 40 of them. Okay, there are 40 of them. So that is basically it for this question. So let's move on to the next one. Okay, so the next one says how many 2-digit positive integers are multiples of 3? Okay, so let's do that one together. So they specify that it has to be 2-digit. So we know that even though 6, 9 are multiples of 3, so in this case, we are not going to be considering them to be starting on any slot yet. Okay, so we can say they have to start at something like 12, 3, 6, 9, 12. So they have to start with 12, and 12 start with a 1, then followed by a 2. I got it. So yeah, followed by a 2. Then from 12 if we keep counting, it goes to 15, then 18, then from 18 it goes to 21. Okay, so we are changing. Instead now of starting with 2, of starting with 1, it starts with 2, so we get 21. Then if we keep counting in multiples of 3, from 21 we go to 24. Okay, so I'm gonna keep a 4 up there, so it's 21, 24, then going up again 20, 7. Then if we keep adding, it's gonna go to 30. Okay, so we see it's no longer starting with a 2, then it starts with a 3. So 30, that is 30, isn't it? Then if we add a 3, then now it becomes 33, then 36, then 39. So it's 30, 33, 36, 39. And if we add a 3 to 39, then it becomes 42. Okay, so we could go on and say starts with a 4, then a 2. But there's already a number that we've seen that it ends with a 2. Remember, from 39, I say we go to 42. Okay, so it starts with a 4 and ends with a 2. So from already the combinations that we wrote here, we see that there is a number that ends with a 2, this one. So we can say 4 can fall in there, starts with a 4, then ends with a 2, 42, isn't it? Then if we add 3 from 42, it's 45, then add another 3, 48, then add 3 from there says 51. So even for 51 it's the same thing. We want the number where it's ending with a 1, so we see this place here, so we can plug 5 there. So it's 51, 54, 57, then 60. That implies 6. We're gonna plug it here since this one ends with a 0, isn't it? Then 63, 66, 69, yeah. Then from then it goes on to 72. The one that ends with the 2 is this one. So it's 72. So that is basically the whole idea of how you go about it. Okay. So you just keep on putting them there. But then the other thing that you have to notice for this ones is that like they have a pattern. If you look at the first digits, you can see it was 1, then 4, 7. Here it was 2, then 5. Here it was 3, then 6. So they are adding up threes here. I'm not saying that's always the case, but for this problem you can see that we keep going up by 3 by 3. So here we can't keep going up, because if we add 3 it's gonna be 10, and that is not what we want. Okay, so here if we add 3 it's gonna go up by to 8. Okay, so let's see if that really falls in, because if we're having 78 and we add 3, that is going to give us 81. So 8 1, you see that it starts with the 8 and ends with the 1, it's 81. So that is basically how it goes. So from here we say 3 6, then if we add another 3 it has to give us 9, just like that. Okay, so yeah, I best believe those are the all possible multiples of 3 that we can get there. Okay, then now let's go on this first one. How many can fill there? 3 of them. Then on this one also 3. Then we add that 2. On this one there are 3 values that can fill that spot, and also on this one 3. Then we add it with, on this one there are 3, then on that one there are 4, just like that, isn't it? So this is basically 9 plus 9 plus 12. So it gives us 30. Okay, so that is the answer. So you have two positive integers that are multiples of 3, 30 of them. You have 30 of them. So feel free to pause the video, rewind, and look at this example again, and get to understand how we do this. Okay, so you can do the same for trying to find the multiples of 5, but then now you will see that you have to put the numbers in accordance to where they have to fall on. So this is basically the simplest way I can think about to project it to you guys. So let's move on to the next question. The next question says that a fair coin is tossed 5 times. Okay, then they ask how many distinct outcomes contain at least one head. Okay, so they have to be distinct. So at this rate, we've been seeing this word too many times. I best believe you all are now understand what the word means. Distinct means that they are different. How many different outcomes contain at least one head, isn't it? So yeah, let us see. To answer that question, I'll say it was tossed 5 times. Okay, so it's 1, 2, 3, 4, 5 times, right? So if you are tossing a coin, what you have to put at the back of your mind is that before you even try to construct a solution for this one, you can think around it this way. Say if you toss a coin, the possibilities are either head or tail, isn't it? So there are two possibilities for all of them. So I want to find the total space of this. So you can say head, tail, head, tail, head, tail. Okay, if repetition is allowed, this one can be accommodated by head, tail, head, tail, head, tail, just like that. So it's accommodated by 2, then multiply by 2, multiply by 2, multiply by 2, multiply by 1, 2, 3, 4, 5. So it's basically 2 to the power 5, isn't it? So 2 to the power 5 is 32. That is 32. So these are all possibilities. There's 32 possibilities. These are the total. This is not the answer to the question. These are all the possibilities. You have two possibilities. Then the question wants where you're gonna have distinct outcome containing at least one head. So when they say at least one head, you can either have a head or too many of them. So it has to at least be there. So if it's not there, that implies how you have to think around it is you at least want to have one head. So in order for you to answer this one, think around it this way. Say, what if I do not have a head at all? Okay, so you have 5 slots. So in order for you to not have a head at all, that implies you have all tails. Tails, 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 isn't it? So if you have all tails, then there is no at least one head in this combination here. Then it implies 1 by 1 by 1 by 1 5 times. So that is gonna be equals to 1. Okay, so this is where we do not find any head. Okay, so if we subtract this number from the total, then we're gonna find where we have at least one head instead of constructing too many of them where we're trying to count where there is a head too many times, isn't it? So we just construct where there is no head at all, so we're only having tails, and we get that the answer for that is equal to 1. Okay, so now from the total, we're going to subtract 1. So the answer to this question is basically 32 minus 1. So we're subtracting 1 because here there is no any head. So we need where there is at least one head. So if we subtract where there is no any head from the total, then the remaining ones there is where there is at least one head. So the answer to that question is 31. Okay, yes. So the next question, let us see. It says how many distinct outcomes contain at least two tails? So basically for this one, we have to think around it a bit. It's not that straightforward like the first one. Okay, so on the second one, I'll need you guys to be with me on this one. So they want it to contain at least two tails. In this case, they want it to contain at least two tails. Okay, so the same approach that we used here, where we are looking for where there are no heads at all. Since here they were talking about heads, there were no heads at all. We have to look for where there are no two tails. Okay, where there can be at least one tail. So since there are 5 like this, we can say 1, 2, 3, 4, 5. You can say there's a head there on the first one, and a head, a head, a head again, and a tail. So this is one of the combinations where there's at least one tail, but here they want for at least two. Okay, so that implies if we subtract this combination, it's gonna it's gonna give something that will be nice for this problem. It's gonna make it more simpler. Okay, so notice that this tail here is not fixed. Okay, so it's not fixed. It can move. So since it can move, what is going to happen is that let's say this tail is accommodating here, so we are counting from there, it's 1, then it can move and come here. When we are rearranging, then it's 2, 3, 4, 5, so it can move 5 times. So here we have 5 different arrangements. Okay, so now since we are looking for at least 2 tails, and here we accommodated for when there is only 1, then this is one of the possibilities where there are no at least 2 tails. The other ones is where there is no tails at all, so having heads all the way. Okay, so it's 1, 2, 3, 4, 5. So if we are having heads all the way, the answer to that one, it's 1, it's the same arrangement, so it's gonna be 1. So it's 1 by 1 5 times, by 1 by 1 by 1. Okay, 1, 2, 3, 4, 5. Yeah, so now if from the total, if we subtract these two numbers, so that the sum of these two numbers, we see that it's basically going to give us 6. So 1 plus 5 is 6. This is where we do not have at least 2 heads. So here, I mean, at least 2 tails. There are no at least 2 tails, so we need at least 2. So this is where there are no at least 2 tails. That implies if we subtract this number from the total, remember the total is 32. If we subtract 6 from the total, so we are having 32. If we say 32 minus 6, what are we gonna get? We're gonna get 26. Okay, so this is when we are going to have at least 2 tails in the outcomes, okay, where they are distinct. So this is the answer to that question, 26. So I understand they can be a bit tricky, and you might find you are still not following of what exactly we are doing. Feel free to watch the video over and over again, maybe at least 2 times. Then if you start getting the jinx of what's going on, you can pause the video and try the problems on your own before you reveal the solutions. Otherwise, yeah, that is part of learning, isn't it? So yeah, let's look at another examples. I've oh, that was the last one that I constructed for you guys. So yeah, this will be the end of the video. Thank you very much for watching. Please like, share, and comment, and yeah, thank you so much.